Back again, we're in 8.8 example 4. This is just an application problem, and we can solve this by completing the square, which has been our topic in 8.8. A landscaper is designing a rectangular brick patio. What I normally do is I will actually draw that rectangle shape. She has enough bricks to cover 144 square feet. Now, anytime you see 144 square feet, you see a squared unit. What they've given you is the measurement for area, okay? So they didn't say it explicitly, but it is implied in this problem that if you have square footage of some sort, square feet, square yards, square any unit, that's a measurement of area, okay? That's what that exponent 2 on your unit means. It's a measurement of area. So she wants the length of the patio to be 10 feet greater than the width. Well, I don't know how long the width is, but all I know is she wants the length to be 10 feet longer than that. So what dimensions should she use for the patio? So I know area, I know length, and I know width. So when you know all three, kind of use your logic here. What formula uses area, length, and width? That's right, the area formula. Remember, area equals length times width. So if I take these things, here's the width, and I'm going to multiply it to my length, and that's equal to my area, look what I've got. Let's distribute. Let me show you kind of what's emerging from this picture as I kind of simplify that left side for you. I have the beginnings of a trinomial, and the A is already 1, so I don't need to divide the whole trinomial by any number. C is already on the opposite side, away from the x squared plus bx. And so now it's just determine what number we need to add to each side. So what we're going to do is we're going to take half of 10, and then we're going to square that. Okay? So half of 10, 10 divided by 2, that's 5. 5 squared is 25. Excellent. Okay? Now what I made here on the left is a perfect square trinomial. I did it on purpose. It was purposefully done. Okay? So x squared, I'm going to just break that into just x. And 25 squared of 25 is 5. The middle term is positive, so I'm going to use a plus sign to connect my x and 5. And then I'm going to add 144 and 25, and that's 169. Now, I need to solve for x, so I need to get it kind of freed up from that square. To undo a square, take the square root of each side. And you're going to be left with x plus 5 equals positive or negative 13, because the square root of 169 is positive or negative 13. So now we're going to create two equations. X plus 5 is equal to positive 13. X minus 5 is equal, or x plus 5 is equal to negative 13. There you go. All right, so let's take a look at our, what do we need to do to each side to get x by itself? That's right, we need to subtract x, or subtract 5 from each side. Here we go. So now I got x equals 8, and then subtract 5, and I've got x equals negative 18. So if this was just a typical non-situation trinomial, and we completed the square to find where this parabola would cross the x-axis, it would cross at positive 8 and negative 18. But because this is a situation, we need to read the situation more deeply. What dimensions should she use for the patio? Now remember, when you are measuring in feet, there's no such thing as negative feet. There's no such thing as, oh, well, my width is negative 18 feet. Well, no, it's not. You can't use a negative number when we're measuring distance and in feet or inches or centimeters. So you got to mark that out. That's what we call an extraneous solution. It's extra, it's a solution, but it's not needed because it does not fit this situation, because we can have negative numbers as sides of rectangles. Okay? So we want to find our dimensions. That's what they're asking us. What dimensions? What length? What width? We call width x. So our width is what we're going to use the positive 8. And then our length, remember from the beginning of the problem, needs to be 10 more than that. And it's 18. And so what our rectangle is going to be is an 8 by 18. That's what's going to end up being 8 by 18 for the patio. Okay? So that's an application of what we've been doing. I kind of brutalized you in examples 2 and 3 by completing the square. Completing the square is not my favorite method. You probably could tell I wasn't all that enthusiastic in my video showing it to you. But it is a way of solving, and if you like it, use it. It's not my favorite, but, you know, hold your judgment until you see 8, 9, and then you can make your decision. I'm going to leave this one as extra credit for you, and it's real similar. Rectangular room, they gave you the area, they gave you the length and the width, you know, information about both. You just emulate what I did to find the dimensions of the room. Because this one's so hard, I'll go ahead and give you 3 points. Okay, so I want to see the work. I don't want you just plugging in numbers and just taking numbers off somebody's paper. Show me the work, kind of emulate what I did above in the space for this one. Okay, good luck and bring your questions to class.